So we all know AI can write code, right? But can it really handle the massive, messy, real-world software projects that human engineers deal with every single day? Well, for a long time, the answer has been kind of no. They get lost, they forget what they just did, they break things. But a new paper from researchers at Meta and Harvard introduces a breakthrough that could seriously change everything. Let's dive in.
Okay, here's the plan. First, we're going to look at why current AI coders are hitting a major wall. Then, we'll unpack a whole new design philosophy that changes the game. We'll meet the Confucius agent and check out its superpowers, explore the wild concept of an AI agent that builds other agents, and then look at the hard data that proves this whole thing actually works. And finally, we'll talk about what this means for the future of coding.
All right, let's kick things off with the big problem. AI coders are hitting a wall, and that wall is built out of the sheer overwhelming scale and complexity of modern software.
And this really gets to the heart of the matter. Look, it's one thing for an AI to spit out an isolated function or a tiny script. That's cool. But it's a completely different universe to navigate a massive codebase with millions of lines of code, hunt down a tricky bug, and then submit a fix that passes all the tests, like a human engineer actually does.
You see, professional software development isn't a quick sprint. It's a marathon. You're swimming in these gigantic repositories of code, working on tasks that can take hours, sometimes even days, and you're juggling a whole bunch of complex tools. This is the deep end of the pool, and this is exactly where today's AI agents start to drown.
The paper really zeroes in on two main culprits, and I like to think of them as the villains of scale. First up, you've got poor context reasoning. The AI just gets lost in the code. They can't connect the dots. And second, there's no long-term memory. It's like a goldfish. It makes the same mistake again and again because it can't remember what it learned 5 minutes ago.
So, this leads us to the paper's core insight, and this is a big one. The solution isn't just to build a bigger, badder AI model. No, it's about building a smarter system around the model based on a totally new design philosophy.
And the key term here is agent scaffolding. Think of it like this. If the AI model is the brain, the scaffolding is everything else. It's the skeleton, the nervous system, the eyes and ears, the whole operational environment that lets the brain actually do its job effectively.
This scaffolding is designed around 3 different experiences. First is the agent experience, or AX. That's the clean, focused info the AI sees. Then there's the user experience, UX, which gives us humans transparent logs so we can see what's going on. And finally, the developer experience, DX, gives the builders the tools they need to actually improve the system.
And check this out. This is a perfect example. On the left, that's the UX. It's chatty, it's human-readable, it tells you what's happening. But on the right, that's the AX. It's clean, structured, machine-readable data. By separating these two, you stop the AI from getting bogged down in all that conversational noise and let it focus on the pure signal.
Okay, so now let's meet the hero of our story, the Confucius Code Agent. It's built on this exact philosophy, and its real power comes from this smarter system that's designed to take down those villains of complexity.
So meet the CCA. And it's important to remember, this isn't just another language model. This is an entire agent system designed from the ground up to handle the messy reality of modern software engineering.
And it comes equipped with 2 key superpowers that are tailor-made to defeat those villains of scale we talked about earlier. First, hierarchical memory, and second, a kind of perfect memory through advanced note-taking. So that first superpower, hierarchical memory, is all about tackling the context problem. Imagine trying to work off a single, endless, messy scroll of every single thing that's ever happened. You'd be totally lost, right? This system basically turns that mess into a structured, compressed summary of just the important stuff, so the agent can keep track of things over long tasks without losing its mind.
The second superpower deals with that goldfish memory problem. The agent actually takes notes. And here's the kicker. As the paper points out, a key part of this is its emphasis on hindsight notes for failures. It doesn't just remember its wins. It carefully documents its mistakes and figures out why they happened. That way, it never has to learn the same painful lesson twice.
All right, now we get to what is, for my money, one of the most mind-bending parts of this whole system. We're talking about an AI that doesn't just write code for an app. It helps build and improve other AI agents.
I mean, think about it. How do you tune and perfect a system as complicated as a coding agent? Doing it all by hand, tweaking prompts and tools, it's incredibly slow, it's difficult. Surely there has to be a better way.
And there is. The answer is, you get another AI agent to do it for you. Yeah, you heard me right. They call it the Meta Agent, and its entire purpose in life is to build, test, and improve other agents.
It's wild. And it works in this really elegant, simple loop. Build, test, improve. You give it a high-level goal, and it builds a new agent to try and achieve it. Then it puts that new agent through its paces, watches where it fails, and then comes up with fixes to make it better. Then it runs the whole loop again, getting smarter with every single cycle.
Okay, this all sounds incredible in theory, but does it actually work in the real world? Let's get to the good part. The proof is in the data.
So on this super tough industry benchmark, the Confucius agent gets a 54.3% success rate. But here's the truly incredible part. It actually outperforms Anthropic's own system, even though they are both using the exact same powerful AI model, Claude 4.5 Opus.
That 54.3% isn't just a good score, it's a new state-of-the-art result. It proves that this entire approach, this new philosophy, delivers absolutely top-tier performance.
And this just hammers home the central thesis of the whole paper, right here. Agent scaffolding, not just model capability, is also a primary determinant of agent performance. To put it simply, the system you build around the AI is just as important, if not more important, than the AI itself.
So let's zoom out. What does all of this mean for the future of building software? What does it mean for how humans and AI are going to work together?
Because this isn't just about a slightly better coding tool. This is a new paradigm. We're talking about a future where AI agents are true partners. They can learn, they can remember, they can even help improve themselves, working right alongside human engineers as genuine collaborators. And that leaves us with a final, pretty provocative thought to chew on. If an AI can learn from its own mistakes, remember what it learned, and then use that knowledge to build better versions of itself, what in the world comes next?